So, in this video example, we're just going to be computing some measures of central tendency in Excel, and then we're going to go over some basics and measures of central tendency in R. In this dataset, we have some different vehicle models, the number of owners, the price of the vehicles, the miles per gallon, vehicle weight, and vehicle length. And in Excel, we just want to find the mean and the median. So the way that we do that in Excel is really easy. Using formulas, we can just type equals in the little box here, average, and then we just select and highlight the range of values that we want to compute an average for. And we get our average of 4,304 vehicle owners. To find the median, we do the same thing. Type median, select the range of values that you're trying to find a median for, and Excel will do that for you, and we get our median value of 3,000 vehicle owners. We can do the same thing for vehicle price. Select our range of values, and we find the average price of these vehicles is about $6,080. We can do the same thing and find the median price, which is about $4,750. Now, if we move over to R, what we can do is go over some R basics and find the measures of central tendency. R makes a lot of this really, really easy, and I will show you exactly how to do it as well. So, the first thing that we're going to do is we need some data. So what we're going to do is create an object called months and assign a list of the names of the months to this object. What this little arrow operator does is it kind of stores lists or vectors or frames in objects with a name. So you can think of months here like a drawer, and in that drawer we're going to store all the names of our months. So if we run that line, we'll see we have a value here called months, and that value contains characters, and there are 12 sets of these characters, and the list of characters is here, January through December. Now, for some of these functions, you're going to need to install a package called dplyr. And to do that, you can navigate to the Packages tab down here, hit Install, and just type the name of the package. It'll come up here, and just hit Install. This won't work on my machine because I already have it installed, but if you just follow the steps, you'll be able to do so. Once you have dplyr installed, you can just run the line, library dplyr, and that pulls up the program and opens it so you can use the functions. Now, we need to create a data frame. So what we're going to do with our little object called months down here is just make it into a data frame. And R makes that very simple with using the command as.data.frame. And what we can do is create a frame called month_frame and store our months object as a data frame in month_frame. If we run that line, we see that we have a data frame now. It's called month frame, and we have a column called months, and it stores all the names of the months. Now, let's say we want to add another variable to our data frame. And we're going to add a column displaying the number of days in each of the months. We're going to call the column num_days, and we're going to add it to our data frame called month frame. What this line is telling R to do is, in month frame, create a column, that's what this little cash sign here does, called number days, or num_days. And in that column, put a list of the number of days in each month. So if we run this line, we can see in our data frame we now have a column called num_days that lists the number of days in each of these months. Now, what we can also do is create a vector, which is the same as just storing a list of names or objects in an object. So right here I have one called ages, and this just takes some random ages of people and stores them in an object called ages. And down here we can see that object we just created. It's a number, there's 1 through 12 numbers, and here is the list of them. Now, using R for our measures of central tendency is very, very easy because it's just the name of the measure, the command, mean, and then the object or the list or the variable that we want to find that measure for. So let's say I want to find the average age in that list of ages that I just created. I would just type mean, parenthesis, ages, and run that, and we find the average of this list of ages is 36.7. We can also find the max age in this list, that is 58, and we can find the minimum age in this list, it's 23. But what if we want to find the mean, the min, and the max inside a variable in a data frame? The #sign operator tells R what variable we are using from a data frame, and the commands look almost the same, but we just specify a data frame and a variable name. So for this one, we're telling R find the mean in the month frame of the variable number days. And the average number of days in the months in our data frame is about 30.4. The maximum number of days is 31, and the minimum number of days is 28. So what if we want to add some data? What if we need to combine a vector or matrix and a data frame? So I have a list of names here, and I'm going to call this list birthdays, because this list of names corresponds to people who have birthdays in specific months. And to add this into my month frame and identify which month the person has a birthday in, we're going to use a command called cbind. And what that does is it'll take our column of names called birthdays, and it'll just paste it onto our month frame. So if I run this line, our month frame will then have a new column called birthdays, and it just lists the names of some of our friends who have birthdays in these months. But what if I want to only work with certain rows in my data frame? What I can do is tell R to only select certain rows or certain columns using the brackets and comma operators. So what this line right here will tell R to do is create a new data frame called month frame 2 from our original month frame using only rows 1 through 6. And the comma and nothing afterwards just indicates that we're keeping all of the columns and using all of them. So if I run this line for month frame 2 and this for month frame 3, we'll see that we have two new data frames that have the first 6 months of the year and the second 6 months of the year, because those are the ones that we told R to use. So now, what if we want to put it all back together? There's a command called rbind for that, and what that will do is it's very similar to cbind, except instead of just pasting a column onto a data frame, it'll take a set of rows and another set of rows and paste them together to make one data frame. So if we do that, we can see that it just pastes everything all back together into one data frame. So let's remove those two data frames that we're no longer going to use, and let's see how we can delete variables from data frames. So we know how to add them. In this line right here, we'll add our ages object that we created to our months data frame. So we've got months, number of days in those months, people with birthdays in those months, and those people's ages. But what if we would like to delete that ages column because we don't need it? What we can do is, there's a lot of different ways to do this, and that's one of the beauties of R, is that there's many different but correct ways to do a lot of different things. So the first way that I'll show you is we can use a subset, and we can create an object called month frame and subset our original month frame, but we can select minus ages. And what that'll do is just drop that ages column from our data frame. So let's put the ages column back. And now let's try subsetting a different way. Instead of selecting the column that we don't want to use and telling R to select minus that column, what we can do is subset our month frame and select only the columns that we want to use. So select equals C will give us a list where we can list the names of the columns that we would like to keep in the data. So right now we have month frame with 4 columns: months, number of days, birthdays, and ages. But if we run this line where we are selecting months, number, days, and birthdays, what that will do is the same thing and just drop the ages. Now, we can also do this with the brackets and commas operators, and we can do this by selecting only the columns that we want. So, if we don't want to include ages, we know we only want columns 1, 2, and 3. So what we do is we create an object called month frame, and we're creating that from our original month frame. We're using all of the rows, but we're only using columns 1 through 3. So if I run this, you'll see it does the same thing again, it just drops the ages. There's a lot of different valid and correct ways to get to the same results when you're using R, which is one of the reasons why I like it so much. So, what if we want to rename our ages variable and give it a more specific label? We can take our month data frame and we can just rename. We're renaming an object in the month frame, and the new name of this object is going to be friend age, and we're renaming ages to friend age. So, if we run this line, we'll see that the column ages is now called friend age. So, there's also logical variables in R that can indicate whether things are true or false. So let's create a variable in our month frame called married, and this just indicates whether or not each of our friends listed in this frame is married. So if we run that line, we'll see that we have all this data about these people indicating whether or not they are married. Right, now let's change the birthdays to the days of the month that the birthday falls on and give the names their own column. So what we want to do is take this birthdays column, right, and take all these names and put them in a new column called name. What this line will do is it just assigns the names in the column of month frame called birthdays to a new column in month frame called name. It just takes them and copies and pastes them. Now, to get birthdays right, we need everybody's birthday. This is a list of the days of the months that everyone's birthday falls on, and what we're going to do is just reassign that to the birthdays column. So now, instead of names in the birthdays column, we have the day of birth of these people, and then we have a separate column for the names of these people. So now, let's add and work with some conditional variables. Let's start with seasons of months. So in our month data frame, we're going to create a new column called season, and we're going to leave that blank for right now. So if we run that line, we have a new column called season. It's blank right now. And in that column, we are going to put winter, where the month is equal to January. And what we do with these bracket operators here is we're telling R in the month frame, in the column season, where the month frame column month is January, we're going to assign the season column winter. So if we run that line, we'll see that January now has the season winter. And we can do this with our other observations as well. This little straight up and down line operator means OR in R. And so we can assign seasons to multiple months using the OR operator like this. It's the same line as above, but now we're telling it where the month frame month is February or December, the season gets winter. So if we run that line, we'll see that February and December are now listed as being of the winter season. And we can do the same thing for spring. So where the month in the month frame equals March, April, or May, season is going to be spring. If we run that line, we'll see that March, April, and May are now listed as spring. So, let's have you practice this on your own and name the names for the summer season and name the months for the fall season. After you do that, we'll move on to more conditional coding, the AND operator. So, let's find out which friend has a birthday on January 6th. What is the name in the month frame where the month is January and the birthday is 6? So we're going to ask R this question right now. In the month frame, in the column called name, where the month frame month is January and at the same time, the month frame birthday is 6. And if we run this line, it'll tell us that Heather has a birthday on January 6th. We can also add variables to our data frame conditionally. In this line, we're going to create a new column in our data frame called weather. And if we run that line, we'll see that we now have a blank weather column. Now, for weather, January is winter, so the weather's going to be cold. So, in our weather column, in our month data frame, where our month is January and our season is winter, we're going to assign the weather as cold. You can also combine the and or operators in the same line. So, what we're going to do for weather here is we're telling R in the data frame month frame, in the column weather, where the month data frame column months is February or the column month is December and the season is winter, it's going to be cold. And if we run that line, we'll see that February and December are now listed as having cold weather. And we can do the same thing down here for March, April, and May. Because they fall in the spring, they're going to be warm. And the fall months of September, October, and November are going to have cool weather when the season is fall. So we can see here these conditional operators assign these values to the months based on the values of other columns. So let's add marital status, right? We worked with that variable a little earlier. So what we're going to do is create a column in our data frame with this line right here. It says marital status, and it just creates a new blank column for us. What we're going to do then is assign values to that blank marital status column using our married column that we had before. So, if our month frame marital status column is blank, we want that column to be assigned based on the married column. So, if our month frame married column is true, then that person is married, and the marital status column receives a value of married, where that value is true in the other column. So if we run that line, and we look, all the people that have true in the married column, their marital status is married. So, we can also use the less than and greater than operators. So let's add a column depicting our friends' favorite foods. We're just going to create another blank column called favorite food. And what if all of our friends who are 40 years or younger love pizza? What we can do is tell R that in this new blank column called favorite food in our month data frame, we are going to put where our friend age in our month data frame is less than or equal to 40, we're going to put pizza. So if we run that line there, we'll see our favorite food for everybody whose age is less than 40 is listed as pizza. Now, let's add sandwiches as a favorite food for everybody whose age is greater than 40 in our data set. So if we run this line here using the greater operator, we'll see that we have sandwiches for everyone who is older than 40. So, what we can do is view our data now in a table. Let's see how many of our friends like pizza versus how many like sandwiches. And we can do this with the table command. So what we do is say table parenthesis, the name of our data frame, cash sign, and the name of the column that we want to create a table of. Now if we run this line, R pops up a little table. 7 of our friends' favorite food is pizza, and 5 of our friends' favorite food is sandwiches. We can also do tables that are a little bit more complicated. So let's say we want to know what seasons are our 40 years or younger friends born in. We can create a table of month frame column season where our month frame column friend age is less than or equal to 40. Now we have some blanks because I didn't assign fall and summer seasons yet in this data frame, but one of our friends was born in spring and is less than or equal to 40 years old, and two of our friends that are less than or equal to 40 years old were born in the winter. So, next, let's add the year that our friends were born, and we can create this by subtracting their age from the current year and assigning that value to a new column in our data set. We're going to create a new column called year born. We have a new blank column. And now, in the column year born, we're going to assign the year 2022, 2023 now, minus the value that is contained in the age column of our month data frame. So, R will do this little equation all for us and store those values in the year born column that we just told it to. Now, let's see which season our friends are born in and what foods they like in a table. You can also use table with more than one variable. So if we run this line here, we'll get a 2x2 table that lists the seasons that we have in our data frame and the foods that we have in our data frame. And we can see here that one of our friends was born in the spring and likes pizza. And two of our friends were born in the spring and they like to eat sandwiches. So, we can also find out what year our oldest friend was born by using the minimum command and finding the earliest year that somebody was born in our data, and that's 1965. What we can also do with the data is create factors. So factors are variables that are nominal, such as gender. We just created a new column by running this line called gender. And this is blank right now, but in this next line we are going to assign the values F and M for female and male to our gender column. And now that we have that, we are going to perform analyses. So, to find out what kind of class a variable is, we use the structure command, str. And we run this command on our month data frame, the column gender. And what this tells us is that gender is a character variable. Now, what we need to do is change it to a factor and store it as a number to be able to run analyses. And we can do that with just doing as.factor, month frame, column, gender. And now, if we run structure on that, we'll see it is a factor with two levels, female and male, one being female and two being male. We can also change things to numeric values manually by doing it this way. We can create a new column called gender number, and for that gender number, where the gender is female, we're going to assign a 0. Now, I'd like you to practice, and using a line that looks like this, add gender equals male is going to get a value of 1. What we can do is take this same line, where gender is male, we'll assign a 1. And if we run that, we'll see our gender numeric lines up to 0 being female and 1 being male. Now, numbers can also be stored as character values, and this doesn't really change anything about the value except that it can no longer be used in numerical analyses. So if we do the year born and just change it to as.character year born, what it'll do is just change those numbers to being classified as a character value. Now, if we try to find the mean of a character value, we'll get an NA and a warning. This is not numeric or logical because these numbers are stored as a character value. We would need to change them back using as.numeric here in order to be able to find the mean. We can convert that back to numeric using these two lines here. And now our year is a number again. And that is it for this video with the R basics and measures of central tendency in R.